Assalamualaikum warahmatullahi wabarakatuh. Hello, welcome back to my video. My name is Antika Nasution. I am a college student from Mathematics Education Study Program 2019 at State University of Medan. In the 13th video, I will explain about the topic the development of modern mathematics from the traditional century to the 21st century. So guys, to hear the deeper explanation, let's check it out. The development of modern mathematics from the traditional century to the first century. As we know, mathematics is knowledge that is constantly evolving from time to time. Since the beginning of human civilization, elements of mathematics have been found, such as numbers, geometry, and so on. The development of mathematics is also based on the touch of figures who want progress for human civilization. The concepts in mathematics are abstract and logical, right? Making mathematics an object that is constantly changing, both change that improve the previous concept as well as change that improve the previous concept. The dynamic nature of mathematics is what makes mathematics interesting to learn. In this video, I will explain about the development of modern mathematics from the transitional century to the 21st century. So I will begin in the 17th century. In the 17th century, witnessed an unprecedented increase in mathematical and scientific ideas throughout Europe. First there is Tycho Brahe in 1546 until 61 managed to collect a large amount of mathematical data describing the position of the planet in space. Then the second is Johannes Kepler in 1571 until 1630 studied the motion of the planet seriously and put forward Kepler's law. He also made a mathematical formula of the laws of planetary motion. And the third there is René Descartes, 1596 until 1650, developed analytical geometry by placing the orbit of the planet onto a graph of Cartesian coordinate. The fourth there is Isaac Newton, 1643 until 1727. In formulating his physical theory, Newton developed a method that we know today as calculus. And the fifth there is Gottfried Wilhelm von Leibniz, in 1646 until 1716. Separately from Newton, Leibniz developed differential and integral calculus. Leibniz also contributed to algebra and topology. He was the first to understand that coefficients of a system of linear equations could be arranged in the rows we now call them matrices to find solution to the system of equations. This method was later called Gaussian elimination. Leibniz is also known as a polymath and philosopher. The sixth there is Blaise Pascal and Pierre de Fermat themes up to investigated probability theory and combinatoric rules in their discussion of gambling. So guys, based on the explanation above, it can be said that calculus, assisted by geometrical analysis, was the greatest mathematical tool discovered in the 17th century. This is evident because calculus is able to solve complex problems before. The ideas in calculus such as limit, continuity, differentiability, and integrability are developed with great care and clarity. The text of reflecting basic concepts become the text of mathematicians at that time who focus on generalizing and abstracting mathematical concepts. And next I will explain about in the 18th century. The most influential mathematician of the 18th century was arguably Leonhard Euler. One of his contributions was the discovery of the study of graph theory with the seven branches of Königsberg for standardizing many modern mathematical terms and notation. For example, it represents the square root of -1 with the symbol e. He also popularized the symbol p to express the ratio between the circumference of a circle and its diameter. He made many contributions in topology, graph theory, calculus, combinatorics, and complex analysis. Another important mathematician of the 18th century was Joseph Louis Lagrange, who did pioneering work in number theory, algebra, differential calculus, and the calculus of variation. There was also Laplace, who had done important work on the foundation of classical mechanics and statistics. And in the 18th century was largely upon exploiting the new and powerful methods of calculus and other fields such as analytical geometry, trigonometry, number theory, and probability. Many mathematical figures were born and helped develop mathematics in this century. There is Bernoulli with his probability theory and the development of calculus to be applied other fields of science or disciplines, especially physics. Besides Bernoulli, there are also other experts such as Johann Heinrich Lambert with proving that p is an irrational number. Then there is Joseph Louis Lagrange with the Lagrange method for solving equation and Lagrange theorem regarding groups, and Gaspard Monge with projecting three-dimensional object on a two-dimensional plane. And the next I will explain about in the 19th century. In addition to developing in the 18th century, in the 19th century mathematics experienced development which were made by three major events, namely, first in the field of geometry, where there was a shift from Euclidean geometry to hyperbolic geometry, which gradually became known as non-Euclidean geometry. The second occurred in the field of algebra. There was a shift from arithmetical algebra to structural algebra, and the last one was the emergence of the field of analysis, a special concentration on the discussion of the real number system, so that real analysis emerged since the discovery of non-Euclid geometry. In the 19th century, the study of the concept of space has undergone great development. In this century, new geometry were born that were free from traditional geometries, which consists of only one form that was not bound to the real form of space. The 19th century was the beginning of the emergence of calculus. Starting from the definition removed from Riemann's doctoral dissertation, this theory became the beginning of the basic theorems of calculus, especially the definition of integral. In addition, Cauchy also very well in the field of analysis mathematics with the definition of Cauchy sequences. Then the next I will explain about in the 20th century. The 20th century saw how the continuous development and improvement of computers, also industry, to deal with a large amount of data to facilitate mass production, distribution, and communication. With this development, new fields of mathematics have also developed, include Alan Turing's computability theory, complexity theory, data analysis, and optimization. In the previous century, most mathematics focused on calculus and continuous function, but the development of computing and communication network made the concept of discrete and combinatoric expansion Expansion, even more important, include graph theory, the ability and the speed of data processing on a computer, enable the handling of mathematical problems that take too much time to do with pencil and paper, leading to files such as numerical analysis and symbolic computing. Some of the most important methods and algorithms of the 20th century include the simplex algorithm, the fast Fourier transform, error correcting codes, the Kalman filter from control theory, and the RHH algorithm of public key cryptography. One of the most interesting mathematicians in the 20th century was Srinivasa Iyengar Ramanujan in 1887 until 1920, an Indian subject who had guessed and proved more than 3,000 theorems, including properties of very high composite number, partition function, and their asymptotic, as well as mock theta function. He also made major investigation into gamma function, modular forms, divergence series, then hypergeometry series, and prime number theory. And the last, in the 21st century, in 2000, the Clay Mathematical Institute announced 7 Millennium Prize problem, and in 2003, the Poincare conjecture was solved by Gregory Perelman, who refused to accept the word because of his critical attitude towards the establishment of mathematics. Many mathematics journals now have an online version such as the print version, and many journals are only published online. There are many observable trends in mathematics, the most portable of which are the subject is getting bigger, computers are getting more important and powerful, the application of mathematics to be informatics is growing rapidly, and the volume of data generated by science and industry facilitated by computer is explosively growing. Okay guys, I think that's enough about my explanation in this video. This is the last video about the topic, the development of modern mathematics from the traditional century to the 21st century. Don't forget to like and subscribe, and if you have any criticism or suggestion, you can write in the comment column. And don't forget to like and subscribe. I say thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.